Welcome! Working on the mathematical issue might get sort of boring. So, in this video, let's take a more general view on the whole processing with mass balance aspect. Besides, I will introduce some useful tools to illustrate the mass balance design. Let's start by taking a look at this flow diagram. It shows the processing by using blocks and flows. In factory design, this kind of graph is called a block flow process diagram. Basically, the diagram also needs to indicate the size and the type of the mass. That is actually what we worked out by the mass balance approach. Let's take a look at the long-term process. If we have all the information about mass, the single unit can be illustrated like this. However, in factory design, we seldom represent these values in the diagram, since it will become too complex with all the details. When we are designing new products without any change to the processing equipment, the block flow process diagram is shown like this. In this diagram, we use numbers to stand for a certain flow. The detailed information is shown in the table. Generally, the information in the table needs to include the flow number, total mass flow rate, and the component flow rate. Sometimes, this diagram can also be accompanied with some extra information, for example, like the operation conditions like temperature, pressure, etc. Pay attention to this table. The mass flow rate unit is kilogram per batch, since the steps happen batch-wise. Don't forget it when doing your own design. Does it still feel as confusing as the first time you saw it? Hopefully not. However, when we look back to the diagram, there are still some problems with it. One of the problems is it doesn't give a good overview on the size of all mass flows. In order to show the process in a more visual way, we can use the Sankey diagram. In the diagram, the blocks stand for unit operations and the arrows stand for flows. Our input flows are located at the same side and our output flows are the opposite side, with the input and output shown by the direction of the arrow. The total width of the input arrow is always equal to that of the output part. This is because the width of the arrow is proportional to the amount of the material in the process. The Sankey diagram is useful in showing any conserved quantity, such as the mass balance, energy balance, consumption of water, etc. The Sankey diagram of the beer processing looks like this. As you can see, it gives a nice visual overview of all the process streams. If we compare it with block flow process diagram, you immediately see that the Sankey diagram indeed gives a way better visual overview. However, the block flow diagram gives much more detail about every mass flow. As the Sankey diagram gives a good visual overview, it also provides possible direction on the future processing improvement. For example, in brewing process, here, our factory design contains a system using recycled water. Actually, the factory processing used to be like this graph. The large amount of water flows out is not only a waste of resource, but also keeps the unnecessary cost of the product. After the processing improvement, the water was recycled in brewing step, which meet both the requirements on cost and sustainability. As you can see, both the diagrams are good at illustrating and explaining the processing steps. There are many kinds of diagrams showing the same thing in the different aspects. Not only the block flow diagram and the process flow diagram, but also a pipe and instrumentation diagram, and much more. When selecting the most suitable one for your work, think about your purpose of the work and the aim you want to achieve. Well, that's all for this clip. Bye!